Okay, this is top questions for the final 27, 30, 35, 37, 38. So we're gonna start. The volume of a balloon is increasing at the rate of 20 centimeter cube per second. So you could say dV over dt is 20. And they want to find the rate of increase of the radius when the radius is 5. Okay, they gave us that V is equal to 4 over 3 pi r cube. And you need to know this. Okay, you need to know if you derive this, guys, what are we going to get? We're going to get dV over dr. And what are they asking for? They want us to find the rate of increase of the radius. They want to find the rate of increase of the radius. So they want to find dr over dt. Okay, so we have dr over dt. We have dv over dt. We can find dv over dr. We want dr over dt. Let's rewrite this. We have dv over dt. Let's multiply it by dv over dr. You know that we want to cancel it in a way to get that to get dr over dt as our answer, right? You know, if you multiply like this, you're gonna get it dv squared. But let's say I came and I flipped this because I want dt to be down, but I want dr to be up. So I'd have to flip this, right? So I could rewrite this as dr over dt. This is wrong, right? I have to flip this. So I'm gonna say dr over dt times dr over dv. Because this way you can cancel this with this and you'll be left with what? dr over dt. Okay? So this is how you solve in your exam. You have to actually write your rate of change, write it in two terms, in terms of two things. So we said dv over dt times dr over dv. And what is dr over dv? It's just the reciprocal of dv over dr. So you just find dv over dr and flip it upside down. What's dv over dr? If you derive this, you're going to get 4 pi r squared, right? So what would dr over dv be? It would be 1 over 4 pi r squared. So over here, dv over dt, we know it's 20. So you're going to put 20. dr over dv is 1 over 5 pi r squared. They want the radius to be 5. So you go and substitute 5. 20 times 1 over 4 times pi times 5 squared. You're going to get 20 over, I don't know, 200 pi. So it's going to be 1 over 10 pi. I don't know. What's the answer? One over 5 pi. How do you... My bad, guys. 25 times 4 is 100, not 200. So 20 over 100 pi. And if you cancel, you're going to get 1 over 5 pi. Yeah, okay. Now we want question 30. Okay, the equation of a curve is y equals 1 over 12 for x minus 3 cubed minus x. They want us to find the derivative. How do you derive this? Let's derive it step by step, okay? To derive the first one, take the constant term on the side. 4x minus 3 cubed. Remember, when you have more than one term under the power, you have to use chain rule. And the chain rule is derivative of the outside, right? Times the derivative of the inside. What's the derivative of 4x minus 3? 4. Derivative of the outside just means take your coefficient down, reduce by 1. Okay? And then derivative of inside is just derive the one inside. Okay? Minus now, what's the derivative of x? 1. So let's simplify this. 4 times 3 cancels with 12, right? So you're going to be left with 4x minus 3 square minus 1. Okay, so that is dy over dx. Let's see. 4x minus 3 squared minus 1. What did they say here? Find the equation of the tangent to the curve at the point where the curve intersects the y-axis. So you guys know to find the equation of the tangent to the curve, you have to use the derivative, right? And we found the derivative. That's why they asked us to find the derivative over here. We found the equation. To find the equation of the tangent, you have to use the derivative. Why? Because, you know, the equation of the tangent is always y equals mx plus b, where m is the slope. And how do you find the slope? You just substitute your point into the equation of the derivative, right? To find the slope, you substitute your point into the equation of the derivative, if you guys remember. Then plus b, you find it with trial and error. Okay, now we need to know what point are we substituting. They said it intersects the y-axis. What does intersecting the y-axis mean? It means the y-intercept. The y-intercept, مثلا if you have a graph like this over here is the y-intercept. And how do you find it? It's when x is equal to 0. Okay? So basically at x equals 0. So if you substitute 0, you're going to get 0 minus 3 squared minus 1. So you're going to get 9 minus 1, which is 8. So we now know that m is equal to 8. This is the slope, right? So we're going back to here. It's going to be y is equal to 8x plus b. How do you find b now? You substitute your point. طب now we know the x coordinate of the point. What's the y coordinate at x equals 0? Some people, what they're going to do is they're going to substitute x equals 0. They're going to use the y coordinate as 8 because they substitute 0 into y prime. But this isn't my curve, right? To know what my y coordinate is, I have to substitute my x coordinate into the original y, right? So it's going to be 1 over 12, 0 minus 3 cube minus 0. If you put this on your calculator, I think you're going to get minus 27 over 12, which is divided by 3, you're going to get minus 9 over 4. Okay. So this is your y coordinate. Okay. This is our x coordinate. So now here to find b, we can substitute minus 9 over 4 equals 8 times x, which is 0, plus b. You're going to get b is equal to minus 9 over 4. So you're going to get that the equation of the line is y is equal to 8x minus 9 over 4. I think. Yes. Okay. Find the set of values x for which the original y is an increasing function. For something to be an increasing function, that means y prime has to be greater than 0. Okay, what was our y prime? We found y prime. Where's y prime? It was over here. 4x minus 3 squared minus 1. Okay, y prime was equal to 4x minus 3 squared minus 1. We know when is this greater than 0? So for it to be greater than 0, we have to study its sign, right? Let's see what are its roots. 4x minus 3 squared. We want to find its root, right? So you take 1 to the other side. Roots means when is it equal to 0? Because you know when to study the sign of any function, you have to see its roots. So it's going to be 4x minus 3 squared is equal to 1. You square root both sides. You're going to get two solutions. 4x minus 3 is equal to minus 1. 4x minus 3 is equal to, what am I right? 4x minus 3 is equal to plus 1. Here you're going to get 0.5. Okay, and here you're going to get minus 4, minus 1. Okay, so these are our roots. So now you can see the sign of it. How do you see it? You remember, we always write our table of variation. So x, y prime, negative infinity, positive infinity. List your roots, negative 1.5. You know, add the roots is equal to 0. Since it's a quadratic, you can use the fact that in between the roots, it's opposite to the sign of the quadratic. The quadratic is positive, right? So in between, it's negative. And outside, before and after the roots, it's always the same sign as the quadratic. So they said, when is it an increasing function? So when is it increasing? When is it positive? When x is less than minus 1 and when x is greater than half. Put this in a bracket. So let's see. So they found the roots for x less than half. Wait. Wait. Do I not know how to find roots? Yeah, hold up. I don't know. I divided wrong. Sorry, this is gonna be positive one. This is positive one. So the roots are x equals 1, x equals half. So I have to erase this over here. This is x equals 1, x equals half. It follows the same rule, just the roots are different. So here I had half, here I had 1. In between the roots negative, opposite to the quadratic. Before and after it's positive. Okay, so for x less than, let me erase this. X less than half and x greater than 1. Let me just half and x greater than 1. Okay. Question, hold up. 35. Okay, we have only 2 questions? No, 3 questions. Okay, a wire 10 centimeter long is cut into 2 pieces. One piece is bent to form a square of side x. The other piece is bent to form a circle of radius r. The total area of the square and the circle is called A, and show that A is equal to this. So for this question, you need to look at the given. They said that the wire 10 centimeter long is cut into 2 pieces. So the length of all of this, let me draw it in red. The length of all of this, which we call the perimeter, plus the length of all of this, which we call the circumference, is equal to what? 10, right? What is the length of all of this? If this is x, this is x, this is x. It's the perimeter of a square, which is 4x, right? What's the length of all of this? Is the circumference of the circle, which is what? 2 pi r. You guys know the circumference of the circle is 2 pi r. So 4x plus 2 pi r is equal to 10. Okay, this is our first given. Okay, we're gonna write this as our first equation. They're saying that the total area of the square and the circle is a centimeter squared. So that means the area of this plus the area of this is equal to a. So a is equal to the area of this. What's the area of the square? X squared. What's the area of the circle? Pi r squared is equal to a. So he's saying show that a is equal to this. Okay, so obviously here they did some substitution. And as you can see here, there's no r. So what did they do? They found an expression for r and they substituted it. Over here in our other equation, that means always this step will show you what you have to substitute. Sometimes there might not be x, so that means from here you need to find an expression for x. This is your key to the whole solving. This here, it will allow you to find an expression for whatever you're looking for. Since I want r, how do I find an expression for r? I'm going to take 4x to the other side. It's going to be like this. Now divide by 2 pi. You're going to get that r is equal to this. But to make my life easier, I'm going to cancel 2 up and down. I'm going to get 5 minus 2x over pi. Remember, when you're subtracting in a fraction, you have to divide the whole thing by 2. Okay, so you're going to get r is equal to this. So over here, I can substitute a is equal to x squared plus pi times r squared. So 5 minus 2x over pi squared. You guys know when you square, you distribute it up and down. So it's going to be a is equal to x squared plus pi times 5 minus 2x squared over pi squared. Cancel the square with the pi. You're going to be left with x squared plus 5 minus 2x squared over pi, right? Now, we have to expand this. So you're going to get a is equal to x squared plus a minus b squared is a squared minus 2ab plus b squared over pi. Okay, see, we would be done here, but here they kept it all over one denominator. And you know, to add fractions, you need to have the same denominator. So this x squared, I need to have pi in the denominator. So what do? Over pi and times by pi up and down. So I'm going to get a is equal to pi x squared plus 25 minus 20x plus 4x squared all over one denominator pi. But still, we don't have the same answer. The x squared, they did something with the x squared. We have pi x squared and 4x squared. Whenever you have a common term, what do? You factor it out. So you're going to get a is equal to x squared pi plus 4. Or no, they put the pi plus 4 first. You see how they put the pi plus 4 first? Why pi plus 4? If you factor x squared out from both of these, you're going to get pi plus 4. So I'm going to take pi plus 4. I'm going to write it first, just so it looks like the equation. Obviously, you won't lose marks for this, but I'm just trying to be organized. Pi plus 4x squared. And then just rewrite it in the same way they did. I put the minus 20x first. Plus 25 over pi. For part B, given that x and r can vary, find the value for x for which a has a stationary value. Obviously, to find the stationary value of it, minimum, maximum, whatever, you need to derive. So we have to find a prime, right? How do we derive this? People will think you can use quotient rule because you have pi. No, pi is a number, guys. So remember, when you always have a number, you can just take it out, put it on the side, and just put it outside and derive the rest of the equation. And then later you can just distribute it back in. Okay? Always, this is what I like to do. Anytime I have like a number that's annoying, I just put it to the side and then distribute it to my derived function. So I can now just get rid of this and derive the rest of this here. Pi plus 4 x squared. Multiply the power and reduce by 1. So it's going to be 2 pi plus 4. Remember, it has to be in brackets, huh? 2 times pi plus 4. Reduce exponent by 1 comes x. Minus 20x becomes minus 20. 25 doesn't get derived. Okay, so you can just put this all over pi. So you're going to get 2 pi. I'm going to just distribute, huh? 2 pi plus 8 x minus 20 over pi. So this is my derived function. So to find the stationary value, remember, always your derivative equals to 0. So this here, my derivative now has to equal 0. So I'm going to take it up one more time. I'm going to get 2 pi plus 8. I'm going to just equate it to 0, right? Remember, for a fraction to be equal to 0, you can cross multiply and solve, but always the numerator has to equal to 0. So 2 pi plus 8 x minus 20 is equal to 0. Take it to the other side, becomes 2 pi plus 8 x is equal to 20. Divide now by 2 pi plus 8 on both sides. You're going to get x is equal to 20 over 2 pi plus 8. Obviously, you can divide by 2 up and down. So you're going to get x is equal to 10 over pi plus 4. So this is the value for x. Remember, we're asking for... Oh, they only want x? Okay, yeah. That's it. Okay, yeah. Okay. If they asked for r, you would go back to our expression for r. Remember, we said r is equal to this. So you take your x that you got here, substitute it there. Okay, but they ain't asking that, guys. Okay. What do we have? 37 and 38. 37. Okay. This came in, I think, in... No, this didn't. It was this one that came in 12 else periodic. So I don't think it will come for us. But you never know. Just do it in case. Let me do 37. So the diagram below shows the dimensions of the garden. The perimeter is 48. Okay, find the expression for y in terms of x. If perimeter is equal to 48, that means you add up all sides, you get 48. So x plus, I'm going to add up the x's first. X plus 2x plus 3x plus y plus 2y is equal to what? 48. So هيطلع لك 6x plus 3y is equal to 48. I'm going to make my life easier. I'm going to divide by 3 on both sides. I don't know. It looks like it's going to be easier. So 2x plus y is equal to 16. So they want an expression for y. So y is going to be equal to 16 minus 2x. Okay. You can do what I did now, but if you want to just continue, add, you can. You don't have to divide. If you want, you're going to get 3y is equal to 48 minus 6x. And divide now by both sides on 3. You're going to get 48 divided by 3, 16 minus 6 over 3, 2x. So you get this, okay? Given that the area is a meter squared, show that a is equal to 48x minus 6x squared. The area of the garden, you have to cut this up either like this into this shape, or you can cut it up like this. Okay? I honestly prefer, I think I'll cut it like this. This looks easier. So I'm gonna get two shapes. I'm gonna get this rectangle over here. And I'm gonna get this rectangle over here. I'm gonna start with the one on the right. The dimensions are x, so here's x. So the width is x and the length of it is 2y. So we're gonna call this R1. I'm gonna call this R2, okay? You know that the area is equal to R1 plus R2. What's the area of the first rectangle? R1, length times width, so 2y times x. Okay, guys, I made a mistake here. Okay, my bad, guys, I made a mistake when adding up the perimeters. Before going to part B, thank you to Jamil Ahmed Khan for mentioning this out. I forgot to count this side over here. So please pay attention to this in the exam. You have this side. I didn't say what this side is. Okay, so I counted this side over here. I counted this side, counted this side, counted this side, I counted this side. But see, this side is missing because perimeter, you add up all the sides. This side here, if this is all 2y, okay, and this part here is y, I want what's left here. So what's left here would just be 2y minus y. So in this case, it would just be y. Okay? So when adding up the perimeters, I'm going to now add the extra y. So I'm going to continue x plus 2x plus 3x. So it was 6x. 2y plus y is 4y is equal to 48. So I'm going to divide... No, I'll just solve. I'm going to get 4y is equal to 48 minus 6x. And I'm going to divide now by 4. I'm going to get 12 minus 6 over 4. It's 3 over 2x. Okay, just divide by 4 on both sides. So, because I was checking the answer key and yeah. Continuing on now to part B, I'm going to continue to what I was doing earlier. It was over here. So R1 and this is R2. Okay, we need to add up R1 and R2. R1 is length times width. So area of R1 is going to be 2yx, right? Area of R2 is going to be equal to what? The length of it is not 3x. Okay, the length of it is 2x. Okay, 2x. And the width of it is y. Okay, so 2yx, 2yx. You see? So 2yx on 2yx. So the total area is R1 plus R2. So it's 2yx plus 2yx, which is just 4yx, right? 2 plus 2, 4. And see here, they're saying show that it equals to 48x minus 6x squared. So they got rid of what? Y. And we needed part A. So we basically found this in part A. Because to get rid of y, you need to find an expression for y and substitute. And we actually found that in part A. So you're going to go now here. You're going to substitute instead of y. 12 minus 3 over 2x times x. So you're going to get 48 minus 1.6 x. If you distribute the 4 and then times x, you're going to get 48x minus 6x squared. Is this the same thing? Yes. Okay, you just distribute. Given that x can vary, find the maximum area of the garden, showing that this is a maximum value rather than a minimum value. We found our area. We want to find maximum minimum. What do? We find a prime. What's a prime? 48 minus 6x. How do we find the maximum minimum? We equate it to 0. 48 minus 6x equals 0. So you're going to get x is equal to 8. Sorry. I derived wrong. Sorry. 1 times 48 is 48. 2 times 6 is 12x. So now if you solve it, you're going to get 48 is equal 48 minus 12x equals 0. And you're going to get 12x is equal to 48. You're going to get x equal to 4. Okay? Okay, so I think I stopped over here to determine whether it's a minimum or a maximum. You guys know to determine something's a minimum or a maximum. Usually we'd substitute and see, when you have two values. But here, when you only have one root, usually, we'd assume it's the maximum, right? And if it's computer part, you can say, oh shit, when they ask you which is the maximum, of course it's this. Yeah. But come on, you have to show if it's in your written part, you have to use table of variation. So, for table of variation, you start with x, and then we're working with a prime. So I'm just going to say a prime. I'm not going to say f prime of x. Okay, and then I'm going to put plus minus, okay? Just to show that it was a minimum. You always you start at negative infinity, you put your root, and then you end at positive infinity, right? At your root, a prime is equal to 0. Before your root, a prime was positive. How do I know that? You can try a point, like 3. 48 minus 12 times 3 is 12. You can put it in your calculator. You're going to get positive value. After 4, of course, it's going to alternate. I told you this many times, guys. Whenever you have a table of variation, it always alternates. Unless your root is a repeated root. وكمان يا أخي 48 minus 12x looks like this. After 4, it was positive. After 4, it became negative. If you don't believe me, كمان, just save yourself time. Try to test a point after 4. Test 5. 48 minus 12 times 5, you're going to get negative 12, which is negative. Okay, what does this mean? We're going to put the dash here. Positive means it's increasing. Negative means it's decreasing. What does this mean? Hence, 4 is a maximum value. Okay, you can see over here. The way they wrote it, they didn't draw it. They just said it's positive before 4. And then they said it's negative after 4. So that means it's a maximum. If it's positive before 4, then negative after 4, that means it's a maximum. That's what they said. Okay, you can put this on a side. You can put this on the side. You can say the derivative, or you can just say a prime. You don't even have to say dA over dx. You can say a prime is positive before 4. And you can say a prime is negative after 4. Hence, 4 is maximum value. You can say this. Okay. هلا 38. Okay. The diagram below shows a metal plate consisting of a rectangle with sides x centimeter and y centimeter and a quarter circle with radius x. The perimeter of the plate is 20. So here's the thing. You have this here, which is y. You have this is x. You have this is y. You have this, which is x, and you have this curved edge here. This is what we call a sector, right? It's an arc, remember? So this is actually, if you continue it, it's part of a circle, right? Oh, that ain't a circle. But like, you get me, okay? But here's the thing, it's part of a circle, but how much of a circle? Remember our formula for calculating the length of the arc? It's always the angle you have divided by 360 times the total circumference. You guys know the circumference of a circle is 2 pi r, right? How much of it are we taking? It's 90 degrees. So 90 over 360 times 2 pi r. So you get 1 over 4 times 2 pi times x, because the radius is x. So this is this part. Okay, let's cancel here just to make my life easier. I'm gonna get pi x over 2. This is here. Let's now continue adding. So the total perimeter is 20. So pi x plus 2 over y plus y. So, sorry, pi x over 2 plus y, so plus 2y plus x, so plus 2x is equal to what? 20. Find the expression of y in terms of x. We want to find the expression for y. Let me simplify these two, okay? 2x and pi x over 2, they both have x. I can factor out x. And I'm going to get pi over 2 plus 2, right? And then I have to plus 2y over here equals 20. Okay, everybody has their own way of solving, but you just have to take everything to the other side, divide by 2. So I don't like it. I'm going to solve my own way, okay? This is the way I like solving. I like factoring first. I have a common. Okay, pi over 2 plus 2, we're going to take all of this now to the other side. So it's going to be 2y is equal to 20 minus x pi over 2 plus 2, okay? We're now going to divide both sides by 2. So we get this, right? Now we have to divide both sides by 2. So you're going to get y is equal to 10 minus x over 2 into pi over 2 plus 2. But whenever they tell you find an expression, it's always better to distribute. Okay, so I'm going to distribute now. I'm going to get 10 minus over 2 becomes over 4. So pi x over 4 minus x over 2 times 2. It cancels out, so it's going to be minus x. Okay, so this is your expression for y. And you can check this over here in the solution. There you go. Okay. Show that the area of the plate a centimeter squared is a equals 10x minus x squared, given that x can vary. The area of the plate is equal to the area of this rectangle plus the area of the sector. Same thing, the area of the rectangle, okay, it's length times width, so it's going to be x times y, plus the area of the sector. Same formula here, except instead of finding circumference, we're now looking for area. So we're going to do 90 over 360 times the area of the circle, which is pi r squared. In this case, r is equal to x, right? So pi x squared. So it's going to be 1 over 4, because 90 over 360 is 1 over 4 pi x squared. Okay, so this is the area. They want it to look like this. They want us to remove the y. So that's where the part A comes in. We found an expression for y, so we're going to substitute that y now. A is going to be equal to x times 10 minus pi x over 4 minus x plus 1 over 4 pi x squared. Let's distribute. A is equal to 10x minus pi x squared over 4 minus x squared plus 1 over 4 pi x squared. Minus pi x squared over 4 plus 1 over 4 pi x squared cancels, because this is the same as saying 1 over, you can take the 4 to the side. It's the same thing as saying 1 over 4 pi x squared here. Okay, so these two cancel each other. 1 over 4 minus 1 over 4 plus 1 over 4. So you're going to get A is equal to 10x minus x squared. Find the value of x at which A is stationary. So we need to what? Derive and equate to 0. Derivative is equal to 10 minus 2x. Equate it to 0. You're going to get 10 minus 2x equals 0. Again, x is equal to 5. Okay, find the value of x at which A is stationary. And they said, find the stationary value of A. So we need to substitute the 5 now into A. Okay, determine whether it's a maximum or minimum. Let's substitute it into A. We're going to get 10 times 5 minus 5 squared. So you're going to get 25. Okay, so the stationary value is 25. Determine whether it's a maximum or a minimum. Let's see. How do we determine? We do table of variation. So we're going to go back here. Table of variation for x, a prime, and plus minus, right? You always start a prime. Negative infinity, positive infinity. Your root is 5. At 5, a prime is 0. Let's see. Before 5, test a point. Let's take 4, مثلا. If you test 4, substitute it into a prime, you're going to get a positive value. That means it's increasing. And then after 5 test maybe 6, you're going to get a negative value. That means it's decreasing. Hence, 5 is a max. Let me see. 5 is the max. Okay, same thing we did. You could have put it on the side, Annie. You could have put, so a prime is increasing for x less than 5, and a prime is decreasing for x after 5, and then you can conclude this. Okay, whatever you want. That's it for the tops, right? Okay, thank you so much for watching. Good luck in your final exam.